So what it is, guys, we're looking at this document. This document is an information release schedule. As you know, everything that's required to go into the program requires information from a multitude of different teams. You know, the estimators, the commercial team, the quantity surveyors, who will be the ones who will work closely with the estimators to initially price the job, look at the different options or methods in which the construction of the actual product or building, commercial, residential, etc. is going to be built. So in essence, this is a mini program for information. So you'd have estimators mini programs for procurement of the work packages. You'd also have the quantity surveyors population of the bill of quantities. Majority of the times, the estimators are the ones who will come up with, you know, how much material, how much resource, etc. is needed. Now, we'll go to this documentation here. We see the site layout, lower ground floor. Initially, this will be through the design stage, okay? So this will interface with the design team's program, okay? You come through all of these different packages. You can see the architectural drawings that will be undertaken in the DTM meetings all the way up, right? Then you look at the piling, all the pile layouts, including setting out. So majority of these are drawings, specifications, etc., all of which will go back and forth between the teams, i.e. the main, say for instance you have a client architect obviously on the job, the design coordinators on their side, and the design team will, you know, basically fire information back and forth in relation to the schedules. Design coordinators obviously mark up drawings, you know, any changes, etc. they will do. We'll stop there and I'll show you a requirement on this particular document here, where it says the examination of drawings. Accurate estimates require a thorough examination of the drawings. You have to, because once those drawings, as I spoke about last week, go straight through to the subcontractors to be procured or manufactured, it's later down the line. So it's past the development stage, right? And what happens is, when it goes towards the right, what happens? There'll be an increase of cost. The cost associated with any change orders to those specifications or the drawings will result in a huge amount being spent. Obviously, the latter into the project it is. So, you look at all the dimensions, right? What you're trying to build is obviously something that will require precision. So, dimensions shown on drawings need to be used to interface the scaling of the drawings as well. So, if a scale is incorrect, there's a high potential that, you know, things are going to be built and built out of place, or interfacing procured works or services, i.e. say for instance the mechanical, electrical and plumbing guys will come in, but the specifications for where they're supposed to run their piping, run their containment, etc. isn't the accurate sizes, right? So say for instance you've built a lift shaft, but the lift shaft cannot actually contain the lift itself, or the specification for the width of the lift was a lot bigger than the specification of the lift pit that was dug in the foundation all the way up. You see, so dimensions, specifications, all of those things have to be done accurately and to the right scale, basically. Now, you also need to look at the scale as well of the drawings. Some of the scales will come in like maybe 100 to 1, 50 to 1, etc. So when you're looking at the actual elevation drawings themselves to try and, you know, basically come up with an estimate of how much material will be required, you need to take that into consideration too, okay? Now, as you can see here, they discuss the need for accuracy, and it does boil down to, well, this as a planner, you need to understand, right? But not necessarily believe that you're going to be involved in this. You will be involved because if any issues are uncovered or any risks materialize during the design phase, it would have an adverse effect obviously later on in the project. So if the issues are not found now, i.e. the prevention technique, you will still obviously come to realize that risk later on through the program, okay? And then you have to go back to the drawing board, and going back to the drawing board would entail you having to call back designers, etc., draw up new specifications, and pay a lot more money, right? So, for instance, the estimator misread a dimension for one of the concrete slabs as 30 feet instead of 300 feet. This is a likely error that could happen, you know, and the other dimension was 100 feet. So the quantity estimated will show 3,000 square feet instead of the actual 30,000, which is what? 300 times what? Times 100. That's why it's 3,000. Do you guys get it? Are you guys with me? Hello?
I said yes.
Okay, alright, cool. No worries. Alright, so...
Basically, it's like a 1 to 10 ratio, 1 to 100 ratio.
Yeah. So you have to make sure that you're very accurate with the estimates. Obviously, not your job, but if you're working closely with these guys and you're also reading drawings, you need to get a whiff of it as well, just for your own side, because this is part of your own visibility on every other person's job. To make sure, remember, you're a process facilitator. You're making sure that all of the blocks fall in place. So before it comes to your estimates, if the estimates are wrong, then the estimates in your program in terms of the duration required to carry out the activity or task will be incorrect, wouldn't it? So you'd have to re-estimate again. You reschedule, you know, attach new dates, you shift out the program. A lot of that obviously will come to your responsibility. So just making sure they've checked and gone over the scalings, the estimates, etc. Looking at, you know, the notes and references on the drawings, etc. Very essential. Errors in scaling as we discussed above, and the wrong quantities. All of this is on a need to know basis, okay? In terms of the estimating, I'll let you guys obviously go back and read through this stuff. It's very, very key to give you an idea of the front end aspect of a design requirement, okay? So it's just for the front end, all the pre-construction, the tender, all of that stuff. This is all very relevant, okay? We'll scroll down to suggested procedure, etc. I'll leave you guys to read all of this. This sort of documentation helps you fill in description, activity number, drawing number. You see, so it's just a little like this document here, right? You can see it's a program. So description, right? Document title here, doc ref. Obviously it will populate with the reference of the documents, okay? So this here is another way. It's built in Excel, but you can kind of see how it would interface into your program, right? Because you're looking at all of these. The pile layouts. This is where you go and look for the scope of what it is you're building, right? If you look at the pile cap and ground beam layouts, fully dimensioned and coordinated, you look at it and you count how many pile caps are on this particular arrangement, okay? So say for instance there were 10 piles, and you know that it takes you maybe a day per pile. You'll be able to estimate it that it take 10 days to finish all the piles, right? Where would you get that information from? You've got this information release schedule, all right? And you know exactly how long it's going to take for the drawings to obviously get populated, i.e. checked over by the design team, the architects, back and forth. As soon as it's approved for construction, you know what date you can then go out to go and procure, or you know what date that the subcontractors can hit site. Okay, so you look at the groundworks, all formation levels are setting out. You know what setting out is. You're basically arriving on site and doing what? You're putting all your plant materials, etc., where they should be prior to what? Commencement. You know, so you look at the below ground drainage layouts. These here were a major issue with Kalish Yard. The below ground drainage layouts, whilst they were looking through the layouts, they didn't identify the electrical cabling that was not made safe by the UK, that which obviously that disruption ultimately led to a delay of 19 weeks. If they had looked at these groundworks information, they would have highlighted where exactly those UKPM cables were, and where exactly the burst mains from the Thames water leak as well was. You see? So connection to public sewer, discharge calculations, details, etc. Why do you need these discharge calculations? You need it obviously because, remember the question I asked you guys? Do you remember? When I said, what sort of elevation would you need to connect existing utilities from a foundation to the sewer system on the manhole by the roadside? Would you elevate it upwards or would you elevate it downwards from structure to the main sewer system?
Should be downwards.
Guys? Collar, are you there? Mike, are you there? It's taking a wee second for it to come back. Okay. Alright, I'll just keep going anyways. So, all of this information here, you can go to anyone.
Again, please?
What's that?
Can you repeat the question again?
Okay, so the question was, if you're obviously building your foundation, right, and the existing utilities, the ground drainage, etc., all the below ground drainage layouts, etc., what would you require? If you're building the foundation, you need to dig the pit all the way to the main sewer system by the roadside. What would you do? Would you build the foundation and dredge the lining of dig the pit of where you're going to pass the pipes through? Would it be elevated at the side of the foundation going downwards, or will the elevation go upwards towards the roadside? Which would it be? Did you hear the question?
Oh yes, I did.
All right then. Okay. So, here we are. I don't know if I can obviously get this document to you guys, but it'll be worth you guys having a look. Okay. But basically, this is all of the information that's required for the build. Okay, it outlines everything completely. This in itself is what it confirms the scope of the whole project. This document, right? The lift, the lower ground floor, etc. Everything. You look at the stairs. So these are the packages, right? So how many packages can you see? Starting from here. The architects, the piling works, the groundwork, substructure, foundation layouts, foundation setting out, interface details with ground beams on walls, retaining walls. This basically gives you all of the scope. So you know it's RC frame. You know there's a basement. You know the lining walls, detailing specification. All of this stuff, obviously you don't need to know the technical aspects, but you need to obviously understand that this is all part of the scope, that it's incorporated, you know, to give you the full visibility on all of the requirements. Okay? So RCP's lower ground floor, reinforced concrete, lower ground floor, first floor, second floor, all of this. It's pretty straightforward. Okay? Alright, so let's go back to our document here that obviously just runs through estimates, etc. I won't talk too much on it because I want you guys to go back and read this particular document. We'll upload it onto the site. So, look at the sort of estimates, end loader capacity, all of this stuff. It's not really your issue, but it's good to just have a read through and kind of get an understanding of what you apply to your resource estimation. That's it. So look at these. Scrapers have two general classifications. You need to know this stuff, right? If you've never been on site, at least know what these things are, know the different types that can be brought. Remember, you're a planner. Your job is to what? Is to define the different options or rationales, i.e. how we intend to carry out the work. What are the specifications? What different options do we have? What are the different methodologies? Do you understand? When you look at the cranes, alright, 3 general types. So already you know there are 3 different options that could be used. The floating or barge mounted cranes. Now, if it's a barge mount, what does that mean? What's a barge? It's mounted on a platform. If it's a floating crane, it'd be floating by itself. So it would obviously have its own foundation, right? Or it could be a truck-loaded crane, as you can see here. Or self-propelled rubber tie. You know, all of these options will not be your decision to make, but it's a good idea to have a general understanding of, you know, the different options available to you. Tractors, you know, earth moving, wheel or pneumatic tire tractors, all of this stuff you don't really need to know, but if you're going to have a requirement for these on site, you'd need to obviously create your resources off of these. If they say to you 5 tractors, you'll ask them, you know, what types are we looking at? Wheel or the pneumatic? You know what the pneumatics are? The pneumatics are like what the you know, the bombers that they use in the wars with the long thingies that shoot. That's what pneumatics are. Okay, truck or crawlers. Cranes, the 3 general types of cranes. You should know that. You know, we had another document that I posted on the site with the different specifications of cranes. You obviously know where the location of the crane should be put. You know the different types of spans that the cranes have. Labor estimates. This is what I think will probably interest you guys a little bit more. Man hours per square meter. You know, that's all you really need to know. So from when you look at the GA drawing, and you could... Hello, guys? Are you with me? Hello? Did they cut you guys out? Well, are you connected into my thing? Alright, so what I was trying to explain to you guys before it cut off was this key area here, the detailed manpower estimates, yeah, will give you an idea of how to measure the required man hours per activity, basically. So these are used to determine requirements for construction of a given project. Once you know the floor print, right? Say for instance 5,000 square foot, 6,000 square foot. The key bit of information is how many man hours is it per square foot. Once you know that key bit of information, which you will get off of the subcontractor or the actual site foreman or the estimators or the quantity surveyors, they would have a general rule of thumb of how long it would take, you know, per activity. You see, so the description of the activities here were exterior spray paint and flat metal. Yeah, for a 6,000 square foot, it would take man hours per unit would be 0.007 man hours per square foot. Yeah, so 0.007 would then multiply the total quantity or size, which is 6,000 square foot, and that will give you 42 man hours for this, to complete this activity. When you divide that by the man days, which is 8 hours per man day, that will give you 5.25. so if you do this calculation again here, you'll get the same here. Yeah, so remember your units, just divide multiply this by that, whatever the answer is, you divide it by the number of man days. Okay, so we have man hours, we have man days. Yeah, and that is a simple way in which you're going to do all of your resource estimates for the, say for instance, slab work, foundation works, columns, beams, all of that stuff. That's kind of how you can kind of resource estimate it. You know, the amount of work required to be done, or the size, or whatever it is, divided by the man hours per square foot. Everything in construction is always per square foot. Okay, so you look at all the factors. Yeah, if you were asked in an interview.
Just a quick one.
Yeah.
You use that sort of stuff for like time risk analysis, time risk thing, isn't it?
Yeah, well, you can. Yeah, the TRA. Yes, yes, you're correct.
Oh, okay. Oh, cool.
You're very correct. Okay.
Yeah.
So, you look at all of these factors affecting production. These are things you will talk about during your interview, right? When you say, okay, you're looking at accurate resource estimation. Obviously, you know that there will be risks, risk impacts on sites. You know, nothing ever goes to plan. Loss of productivity, loss of throughput, output, efficiency, all of that stuff. And then you then relate it to factors affecting the productivity of the man or the trades or gangs, etc. In preparing man-hour estimates, various factors which will affect the labor required to construction project must be weighed in. So this is where you then include the time risk analysis. As it says here, these factors are weather conditions, obviously all the force majeures during the skill, the experience of the men who will perform the works, the time allocated for completion. You know, all these are all external factors, but you have to take all these factors into account, and then you come up with the time risk analysis aspect of this, of the resource estimation. Okay, and then you look at the workload. This is just basically resource optimization. You know, the time allotted for construction obviously has a definite bearing on the number of workers assigned, or gangs assigned to the work. Rush jobs may require a crew working long hours and obviously different shifts, 3 shifts of 8 hours, 8 hours, 8 hours. Yeah, so that's literally what they're just explaining here. All of these will have an impact. It's good to have a general understanding of the processes or procedures of such works, so you can relate it, obviously, in terms of your interview questioning. When they say to you, okay, what sort of things have you encountered on site, etc., you can come up with, you know, these as a commentary. You see? So, as you said, the workers' production per hour decreases sharply under these conditions. As you can see, sometimes it's better to increase the number of workers in a crew, or work on several crafts at the same time in one location in order to complete the job quickly. Do you see that? So this here is a good interview answer. When the work area is crowded, workers are likely to get in each other's ways. So this is the reason why we always sequence the work in such a way that there won't be any issues with the trade interfacing, right? So one finishes, the other one can start, as opposed to one finishing or almost finished and then the other one has already started. You know, there will be conflict of resource. Okay, so you have to take that into account and obviously optimize it accurately. You know, giving yourself enough of a duration for one to complete the task and for the other successor activities to follow on. So basically, the size of the crew. It doesn't mean that if you throw so many resources at a task that you will complete it in the required time. If you're doing any maybe acceleration, or you're doing trying to crash the critical path. Why? Because the productivity levels will still be the same. No resource can ever perform at 100%. Even plants will never perform at 100%. So in the specifications of the crane, for instance, if the crane specification says, obviously, in terms of the health and safety requirements, this crane cannot lift anything more than 70 tons at a 45-degree angle. What does that tell you? The acceptable or the capacity or the capability of the crane is what? 70 tons. But health and safety will probably say to you that we don't want to lift 70 tons. We want to lift 50 tons. Just in case. Okay? So that already decreases, you know, increases the length of time it will take the crane to obviously lift stuff. If we're lifting a lot of heavy stuff, we'd obviously have to put it in batches of 40 or 50 tons per lift, right? Maximum. You see? Here we are. Electricity guys and the utility men have to work at the same time in the area, working 12 to 14 hour days. The efficiency factor can be as low as 30. You see that? As low as 30. Why? Because you have a long stretch. 12 to 14 hours a day is a long time. So the man hours you're looking at, if you estimate it at say 8 hours per shift, in the long run it will pay off. As opposed to you having men working 12 to 14 hours, how many breaks will these guys take? When will fatigue set in? How much productivity will you get out of them? This is where you can kindly say, okay, for the ones who perform their job specifically and are skilled, etc., you can say after 6 or 7 hours, their productivity levels start to drop from 80% to 40 or 50, right? You can apply all of those type of techniques into your resource estimation. You know, the site area, the space for equipment maneuverability. Say, for instance, you're fitting high-level lighting equipment. You bring in a mobile crane, right? You bring in the mobile crane, you fit in the high-level stuff. Then the electrical, the the ceiling guys want to come in straight after you finished, right? What happens? Will they still need that mobile crane? Of course they will. Will the guys who are doing the floor screening, etc., also need that mobile crane? No, they wouldn't. If they want to do it concurrently or run their jobs concurrently, what would happen? You'd have a bottleneck with the mobile crane within the building, right? So, accessibility.
Yeah.
It can affect labor requirements for a project. We all know that. Obviously, if the specifications ain't right, you know, you build a door that's supposed to be 10 meters wide and you need to bring in a mobile crane that's 15 meters wide. What happens? You have a resource, you have a constraint, right? It'll be inaccessible. And that would obviously cause disruptions. And prolonged disruptions will always be delays. You see? So here we are. You see what they said? 25 to 30 efficiency may reduce to 25 to 30. An example, ideal working conditions, large working area, no restrictions on use or equipment maneuverability, all materials stored at the site, easy access, will rate high as 80s productivity efficiency in that area. So it never goes above 80. You see? So a school graduate, blah, blah, blah. You see, they're just saying the same thing. It's very difficult to get 100% productivity. So if you're assigning resources to activities with the assumption that they will perform those activities to plan, right? And you've estimated a particular amount of time, the assumption is that they will perform at a scheduled performance index of 1. And also a cost performance index of 1. Right? That's the assumption. Remember, estimation is an assumption of how long the duration will be. Are you with me, guys?
Yeah.
Okay, so the rest of these, I'll just leave it to you guys to kind of read through. I want to go straight into the program so we can kind of, you know, look at how we can apply that. Okay, so look at these as well. Production efficiency guide chart. Average production, low production, average, high. 85, 95, which is very rare. Workload, construction requirements, high, miscellaneous overhead, high. Construction requirements, average, miscellaneous overheads, average. Construction requirements, low, miscellaneous overhead, low. high production. Why? Because if you've got guys working at 85%, you won't need more people, would you? That's basically what they're trying to describe here. Supervision, labor, poorly trained, motivated or inexperienced. Adequately trained, motivated crew. Highly trained, motivated crew. So you see the categories. It's been categorized for you. This will be good for you guys, right? So you just literally just say labor, site area, issues with program, issues with work on site. These are the issues that you have come across. Scaffolders came in, or the temporary works guys came in. They weren't necessarily as skilled as, you know, you say for instance you prepare a package for 100k, and then another subcontractor comes with a lower bid of 80k. The first things that will jump at you within their bid submission will be, are the guys who they're getting on site skilled enough? Will you get low productivity, average or high? All of these are different rationales or different options or different methodologies, yeah, that you would have to take into account in order to achieve the objectives and deliverables of that particular activity. Okay, so rainfall is normally treated in the area. Calendar day scheduling, prediction of lost construction days are based on okay, yeah, we don't really need to read through this, but yeah, you can do that. Production efficiency graph, very interesting. Delay factor, you see that? The delay factor is higher, obviously, when the production percentage. So you see, already you can produce a graph of this in terms of your reporting. This is also part of your performance measurement or baseline measurement or performance control, etc. The execution phase, obviously monitoring control. This is the sort of stuff that you'll be producing. Labor estimate tables, man-hour labor tables contained, you know, these are things you may not necessarily do depending on the complexity of the project and the reporting requirements, but it will be a good to know. So if you probably just spend maybe an hour going through this document and trying to, you know, kind of understand what the requirements are, this feeds directly into your roles as planners, right? If you're able to give commentary on all of these labor estimates, remember it's all about the key terms. Labor estimate tables, etc. are prepared. You know, look at this, for instance, 17 major divisions of work. Beautiful, beautiful division here, you see? And this is generally the sort of trades that you would like to see on a site. Site work, concrete, masonry, metal, carpentry, moisture protection, you know, look at it. Finishes. It's beautiful. What more can you ask? I love this. So now, how to use it, labor estimate tables. You know, we haven't got a table here, I'm not sure, but let me try and see. You know, all of these terms are quite interesting. You see, this is now the real planning, right? Not just attaching estimates. Oh, it's going to take 5 days. It's going to take 6 days, 7 days. Why? Because you've asked someone a question. How realistic are those dates? What sort of qualitative or quantitative analysis techniques have you applied? What numerical values have you attached to those durations? It's always good to have a rough idea of any sort of technicalities that you can apply to your estimation, so it gives you a higher degree of freedom or higher degree of confidence. Remember, everything with estimating is the degrees of confidence. If you're confident that, say 100%, that this is going to take this amount of days, you know that you've accounted for the risk, you know you've accounted for any delays or disruptions, both externally and internally, right? And what would be the end result if you perform at the required productivity levels? You would obviously achieve the required deliverables of those activities on time and on budget, right? It's also what? Are you with me?
Yes.
Okay, so these are examples I'm sure you can, you know, kind of work your way through. You don't need to know these calculations. It's just a good to know, right? That these things exist. Very interesting. you can kind of work through and give your rough estimates. So you look at all of this miscellaneous site work, hand site. This will give you a good understanding of where majority of the risks will be on a construction site, right? Gives you a good idea. Acres, length of one site. Oh, mate, this is beautiful. You know, soft strip, hard strip, all of that stuff. Just read the definitions and approach these documentations. Anything you don't understand, copy it straight into Google. It will give you a description of exactly what it is. Right? Look, doors and door frames, 3x7 wood door frames each. Man hours per unit. You see? So if you're going to estimate how long it's going to take them to complete, say, 50 doors on a floor, what would you do? You come here, you look at this. If it's a wooden door frame, you know it's going to take you what? 2 man hours per unit. So if you have 7 doors in one apartment, how long is it going to take one man to finish those 7 doors? If one of them takes 2 hours, it will take him just slightly 2 hours less of a day, because two man days will be what? 16 hours. And if it takes him 2, right, per one, and there's 7 doors, that's 2 times 7, that's 14 hours. And if he's working 8-hour shifts a day, that will be 2 days approximately, right, give or take, inclusive of the time risk. Yeah. So
Okay.
this is literally, you can always just come here and take these bits of info, right? When you're building your schedules or your programs. You get it? It's a fantastic way to obviously do your resource estimation. You know, so I'll try and attach it into the site now so we can literally obviously have access. The rest of it, just kindly read through at your leisure. Let's go over to the programming. And what I literally wanted us to do was just kind of look at these durations, yeah, and look at how realistic they are. We won't do the front end of it, yeah. We'll do the back end, which is the fit out aspects. Okay. Are you with me, guys?
Yeah.
All right. I'm gonna pause the recording just so you guys can ask questions. Yeah.